Let's look at problem 5 in OpenStax College Physics, Chapter 28. A neutral pi meson is a particle that can be created by accelerator beams. If one such particle lives 1.4 times 10 to the negative 16 seconds as measured in the lab, and 0.84 times 10 to the negative 16 seconds when at rest relative to an observer, what is its velocity relative to the lab? So let's try to figure out what the problem is saying. We are given two different times. We have the 1.4 times 10 to the negative 16 seconds. So I'm going to call that delta t. So 1.4 times 10 to the negative 16 seconds. And then we have another time, which is 0.8. So another delta t is 0.84 times 10 to the negative 16 seconds. Now I'm going to compare the two times that are given for the same pi meson, and notice that the second time is actually shorter than the first time, so that is most likely the proper time. Also, later on in the problem, we're asked to find the velocity of the pi meson relative to the lab. So that means that the lab is measuring a different time than the time that the observer at rest with respect to the pi meson was measuring. So the observer at rest in the frame of the moving pi meson measured the proper time, whereas in the lab, an observer in the lab will measure a different time, and that's going to be the dilated time. So now we're looking for the speed. And now that we know the knowns and unknowns, the rest is just plugging in into the equation. So we know that delta t is delta t naught divided by square root 1 minus v squared over c squared. So if I rearrange this, delta t naught divided by delta t, I'm going to square it right away, is going to be equal to 1 minus v squared over c squared. So I'm basically doing algebra and skipping a few steps. So then v is going to be c square root 1 minus delta t naught divided by delta t, quantity squared. And then we plug in the numbers. C square root of 1 minus delta t naught is 0.84. I'm going to skip the times 10 to the negative 16 because those will cancel out anyhow. Divided by 1.4 times 10 to the negative 16, quantity squared. And when you do the math, then you end up with 0.8 C. So again, the difficult part about relativity is figuring out which is your proper time and which is the dilated time. So that's the stuff that is the hardest to understand in these types of problems.